Hey, welcome back, everybody. I hope you all had a wonderful spring break. Okay, today we're just gonna keep chugging along here. Chugga. Right into chapter 8. Chapter 8. And what we're going to do today is we're actually going to knock out 2 lessons in one. All right, so we're going to be talking about ratios and proportions today, and they are very, very, very similar. That's why I'm grouping them together. So ratios and proportions coming your way. Here we go. So today what we are going to do is we are going to write and compare ratios, but also we're going to look at the same thing with proportions. Okay. We're going to be dealing with both ratios and proportions. So the very first thing we have to do is know what a ratio is. So I want you to pause now and write ratio down. Pause. All right, so if you look at a ratio is a comparison of two quantities by division. Okay, so when you look at the ratio of A to B, it can be written as, you can have a semicolon here, it can be written as A colon B. You can write out the word A to B with 2 being just T-O, not T-O-O or T-W-O, just A to B. And then, or it can be written as a fraction as well, because we all know that fractions can show two quantities are dividing each other. Okay? Notice the entire time, when I am writing the ratio of, right here, A to B, notice A is always coming first. Okay? A is always coming first. So if I'm writing a ratio of A to B, A has to come first. If I was writing a ratio of B to A, it would all be opposite. It would be B colon A, B to A, and B over A. Okay, so whenever it all depends on what number, what quantity, whatever you want to be talking about, whatever comes first, that needs to be written first. Okay? Sweet. All right, so now we also have what's known as equivalent fractions. So pause now, write this down. I do need to draw a little line here. This 28 to 20 goes right here. And pause and write. All right, so when you look at equivalent ratios, essentially it's the exact same thing. It's ratios that make the exact same comparison. So if I look at this, if I'm looking at this left figure here, notice I have seven shaded squares, and I have 5 non-shaded squares. Okay, so when I do, that would be a ratio of shaded to non-shaded. Okay, and it would be 7 to 5. If you look at the drawing for 7 to 5 and the drawing for 28 to 20, you'll notice they are the exact same. Okay, if you started dividing all of these up, okay, as squares, you will notice there are 7 shaded squares. 1, 2, 3, 4, 5, 6, 7. And on the other side, you will notice that there are 5 unshaded squares, 5 large ones. 1, 2, 3, 4, 5. Okay, but in all together, there's 20 total non-shaded and 28 total shaded. All I did with my with a ratio or an equivalent ratio, you can just take 7 to 5 and multiply it by any number. As long as you're multiplying both numbers, okay, by the same number, it's going to be an equivalent ratio. Equivalent fractions and equivalent ratios are essentially the same thing. Okay, remember when we talked about equivalent fractions of 2/9 and we multiplied them by 10, by 20, by 30, by 100, whatever, it would be 20 over 90. Okay, these are 2 over 9 and 20 over 90 are equivalent ratios. They're equivalent fractions, they're equivalent ratios. So, equivalent ratios meaning equal. Whenever you see that word equal. All right? So we have this table here. We have three teams, the Padres, the Dodgers, and the Cubs. What I want you to do is I want you to write a ratio for the following statements. Okay, write the ratio in the simplest form. So the very first thing is you have to pick one of the three ways you can write a ratio, either with the colon, with the word to, or just as a fraction. Personally, I would go with fractions, but that's completely up to you. Then what you have to do is you have to figure out how the ratio, what it lines up. Remember when we talked about A to B? Okay, A was always came first. Okay, you figure that part of your brain is going, and then what you have to do is make sure it's in simplest form. So what I'm going to do is I'm going to help you with this very first one. Okay, it says wins to losses with the Padres. Okay, so I'm looking at the Padres. Find the Padres right here. Okay, wins to losses. How many wins did I have? 16. How many losses did I have? 11. Okay, so if I look at that, 16 and 11, well, it's just 16 over 11. And that's my ratio. Is that in simplest form? Absolutely. Those two numbers are relatively prime. Okay, I want you to try the exact same thing for 2 and 3 for the Dodgers and the Cubs. Make sure you read these carefully. Okay, read them carefully. Give it a shot. All right, so if you look at wins to games played. Ooh, remember when I talked about reading there carefully? I almost didn't. Okay, so wins to games played. So how many wins did the Dodgers have? 18. They had 18 wins. How many games did they play? Well, we know if a game is going to be played in the major leagues, it's always going to be a win or a loss. There's no ties in baseball. I don't think so. Not in the majors. Nope. Okay, so if you look at 8 and 9, when you add those together, there are 27 games played, total games played. Simplest form, you can divide both of those by 9, and you come up with 2/3. So 2 over 3 is the exact same. It is the exact same fraction or equivalent fractions. Or equivalent ratios. If you look at what does this signify, it says wins to games played. That means for every 3 games, okay, every 3 games that the Dodgers played, they would win 2 of those. Okay, and that's what that ratio is describing. Okay, last one, losses to wins with the Cubs. Okay, losses to wins. How many did they lose? 14. How many did they win? 17. Is that in simplest form? You betcha. Okay, and we're done. So that's ratios. Okay, remember your first, whatever comes first is going to be, so wins to losses with the Padres. Wins comes first. 16 came out as my numerator. Wins to games played. 18 was the games played. I simplified it down to 2 later on. Losses came first. Okay, if you had, you could have the 16:11, 2:3, 14:17 for that last one, or you could actually write out the word 2. Notice this word, you see these words 2 here going straight down. Okay, you'll notice that you're making a ratio. Awesome. Let's keep going. All right, so now Luis and Amber compared their CD collections. Who had the greater ratio of country to pop CDs? I want you to give that one a shot. Then rap to country. Who had the greater ratio of rap to country? Give it a shot. Okay, so the very first one, we have Luis and we have Amber, and we're going country to pop. Country to pop. So if you look at that, country to pop, there were 9 countries to 16, or sorry, not pop, that's rap, to 42. Okay, then we had Amber, who had 42 country and 70 pop. Okay, so when you look at this, I'm going to put this as a fraction. Now the question is, which one is going to be greater? Okay? Remember how we can find which one is greater? You find out which one is bigger, which one has the bigger fraction. Okay, so if you put it into decimal form, which one is greater? That's the question. Okay, fractions, ratios. You're going to see a lot a lot of fractions when we're talking about ratios and proportions. So essentially, which one is bigger, 9 over 42 or 42 over 70? Which one is it? Ding, ding, ding. Amber knows our country. Okay, and I know you all want to be just like Amber, so just make sure that your CD collection has that country in it. Have to have that country, because it's the best music in the world. Besides my singing, of course. Of course. Okay, next one. Rap. To country. Who has the greater collection? There's Luis and there's Amber. Okay, Luis, his rap is 16 to 9. And Amber's is 25 to 42. And when you put these as a fraction, 16 over 9, 25 over 42, which one is larger? That's going to be Luis. Remember, I look at my fractions and I compare those two fractions of 16 ninths and 25 42. So the first question is Amber. Second question is Luis. Sweet. All right, here we go. So now it says write the ratio of the first to the second measurement. Then we need to make sure that is the same unit. Okay, so when I look at this, okay, as I'm sitting here looking at these two problems, very first thing is, in your head, what I want you to do is I want you to make sure they have the exact same unit. Then I want you to make sure that it's going to be in simplest form, because you still need it in simplest form. All right? So give this one a shot. See if you can come up with it's a ratio between the first to the second. Okay, so the first one is going to be 5 feet. Second one is 10 inches. Make sure it's in the exact same unit. Simplest form. Give these two a shot. Go. All right, so this very first one, if I had to make a ratio of the first to second, 5 feet to 10 inches. But remember, it also needs to be same unit. So which one am I going to switch? Am I going to switch feet or am I going to switch inches? Well, I can easily make 5 feet into 60 inches because I multiply by 12. And since 10 inches is already in inches, I'm going to leave it as that. Okay, and the reason why I changed my feet to inches is because if I try to change 10 inches into feet, that's going to be a decimal. I don't want to deal with a decimal and a fraction. No, that's ugly. Okay, so this is 60 inches to 10 inches. And when we simplify that down, it's going to be 6 to 1. All right, 6 to 1. I divided by 10. Next. All right, same thing. First unit to the second one, 7 minutes over 25 seconds. Okay, which one is going to be easiest to switch? Well, if I make the easiest switch, I'm going to change my minutes into seconds. So multiply that by 60, and I get 420 seconds to 25 seconds. Now, can I simplify that down? That's the true question. Can I simplify this down? Yeah, I can divide both of these by 5, right? You betcha. So the bottom one is the easiest. That's 5 seconds. And the top one, 420 divided by 5, that is going to be 84. So I have 84 fifths. And I'm done. Donezo. Sweet. So that is ratios. Ratios. And do you actually, I apologize, you don't need that unit at the very end there. If you want to put it in there, fantastic. But you don't need that because we're talking about the exact same unit. Okay? Okay, so what a proportion is. So pause now, and I want you to write this down actually before I start talking. So pause, write it down. All right, so if you look at proportions, proportions are two ratios, or they're going to be ratios that are equivalent. An equation showing that two ratios are equal, essentially. So if you look at 1/12 is equal to 2/24. Remember when we talked about 7 fifths and 28/20. This could be called a proportion. They're equal to each other. They are equivalent. Okay? So what we are going to be doing is we are going to be making equivalent ratios. All right? And there's one way to do that. And I'll show you. Okay, so what I want you to do is I want you to pause now, write all of these down. If you have any idea on what to do, I want you to give this a shot. If you're not sure, just pause. Then I'll be back in just a second to explain this to you. All right? Give it a shot. All right. So when we look at two proportions, notice we have a variable here. Okay, we have x. What we want to do is we're going to be solving for x essentially. Okay, and how we do that is what's called cross multiplication. Okay, if you've ever done it, fantastic. You know where I'm going with it. If you haven't or you don't remember it, let's go. So cross multiplication, essentially, you cross and you multiply. Gosh, I love when it just spells it out there. And remember, you can use your calculator, so make sure you pull those out. Cross multiplication, you are crossing. So I take 126 times 9. And then on the other side, it's going to be equal to 27 times x. Okay, well, we know 27 times x is 27x. And when I take 126 and I multiply it by 9, I get 1,134. That is a 3 there. 3. Thank you. Okay, so now we're back into our one-step equations. All right, so you cross multiply. So cross the numerator times the denominator on the other side. Same thing, do that to both fractions. Okay, and then you get a one-step equation. Well, how do I solve for this? I essentially now have to divide by 27. I want to get rid of that 27 to get all of my x. So x is going to equal 42. And I'm done. Sweet, sweet. Okay, so what I want you to do is I want you to cross multiply. Multiply the bottom number. Notice I took 126 here and multiply it by 9. And I did the exact same thing, 27 times x. Then I just solved in my one-step equation. Give this a shot for the other three, and then I'll go through them. And we're almost done here. We have one more slide. One more slide. All right. Give it a shot. All right, here we go. Okay, next one. I'm going to take h over 33 is equal to 2/6. I'm going to cross multiply. So I have 6 times h is equal to 2 times 33. Cross multiplied here. I have 6h is equal to 66. Then divide by 6 on both sides. And I get h is equal to 11. Nicely done. Okay, next one. Again, I cross multiply here. I have 25 times 12. And then I have 30 times s. That is an s, by the way, not a 5. That is an s. Okay, so 25 times 12, and you come up with 300 is equal to 30s. Divide by 30 on both sides, because it's a one-step equation. S is going to equal 10. Last but not least, we have 14/4, and 49 over g. Cross multiply, I take 14 times g. Then that's going to equal 49 times 4. When you multiply all of this out, you get 14g. 49 times 4 is going to be 196. How do we solve for g then? We divide by 14. Divide by 14. And g is going to equal 14. Awesome. Proportions are two equal ratios. Cross multiply. Take the numerator of one and multiply it times the denominator of the other. And then go through your one-step equation and solve. Okay, and you'll come up with the correct answer. All right. All right. Here we go. Like I said, this is the last slide. And I'll give you your homework and I'll explain that. Okay, so pause now and write it down. All right, it says the ratio of the number of bones in a human's ears to the number of bones in the skull is 3 to 11. Okay, so that statement right there is very important. Number of bones in a human's ear to, so this is going to be our first part, the number of bones in the skull. Okay, and that's our second part. So we have number of bones in a human's ear and a number of bones in the skull. So that's 3 to 11. So there, I'm sitting here and I'm thinking, all right, ears, skull. Okay? Then it says there are 22 bones in the skull. How many bones are in the ears? We are going to set up a proportion. And what I want you to do, we know that there's 22 bones in the skull. What you have to figure out is how do I set up a proportion to find out the number in my ears if the ratio is the exact same. Okay, so I want you to pause now, come up with a proportion. Try to come up with a proportion. If you do, I want you to solve. All right, so you're writing a proportion and you're solving a proportion. I love saying that word, proportion. Say proportion 5 times fast. Proportion, 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 proportion. I couldn't do it. I want to hear you. Say it out loud right now. 5 times. All right, I hope you just got a funny look. All right, here we go. So, pause, give it a shot. All right, so when I look at this, my very first fraction, remember, we're two ratios that are equal. My very first ratio is 3 to 11. All right, what I have to do is I have to use the number that I come up with or that I figure out right away, use that ratio, and the number that they give me of 22 to figure out where I put that. Now, if I look at this, I put ears over skull, right? The number of bones in a person's ears over the number of bones in the person's skull. Remember, because that ears came first, okay? So I put ears over skull, and I don't know how that doesn't, that looks like skull. Okay, that ratio, how I did that has to be the exact same thing on the other. Has to be ears over skull, the number of number of bones in a human's ears over the number of bones in a human skull. So it says we know that there are 22 bones in the skull. Well, we need to figure out where do I put that? Well, ears is on top, skull is on bottom, so skull goes down here. 22 bones. Because on the left side, and I'm talking about this proportion right here, on this left side, okay, I looked at ears over skull. I need on the right side that exact same ratio of ears over skull. Do I know how many ears are in, how many bones are in the ears? No, I don't. Okay, and that's where I'm going to put my X. Okay, so here I put ears over skull. On the right side, ears over skull. I knew that the first ratio was 3 to 11, so 3 over 11. My next equation, because I put skull on bottom, my number of 22 goes on bottom. I am now going to cross multiply here. I get 3 times 22 is equal to 11 times x. When I solve here, I get 66 is equal to 11x. And I'm going to divide by 11 on both sides, and I get x is equal to 11. Now, sorry, x is equal to 6, not 11. Running over my words. Now, however, I am wrong right now. How am I wrong? Story problem needs a label. Okay, so 6 bones is the answer. All right, that's what I have for you. What you are going to do is you are going to do your work. So what I want you to do is, now that you are done with this video, I want you to go over and ask the teacher for a worksheet. Okay, you are going to be asking for your homework. Lucky you, I'm so excited. Okay, and what you are going to do, it says 8.1 and 8.4 worksheet. It should be a front and a back. Okay, and I want you to just do the evens. Do not do the odds unless you want to. Unless you want to. Okay, so just do the evens. Evens, evens, evens. Evens, Steven. Okay? I hope you enjoyed your spring break. Welcome back. I am excited to see and hear from you tomorrow about them. So get to class tomorrow early during religion tomorrow so we can talk. Awesome. See you later.